Okay, we are picking up where we left off yesterday in 4.8. No. Yes, 4.8, right?
Yes.
Okay, thank you. Sorry, I teach too many classes. I get my lesson numbers confused. So we're picking up where we left off in lesson 4.8. My plan is to finish the notes. We'll probably skip a couple of the division, but my plan is to finish the notes to the point where you know how to do everything for homework tonight, with the homework being due tomorrow. Okay, so plan accordingly. I asked you guys to look at D. Your job is to multiply, because notice it is in the multiplying section, -4 plus 5i and -4 minus 5i. How do we multiply these?
Foil.
This is FOIL, right? Notice there is nothing in between the parentheses. We talked about this difference yesterday. There's nothing in between the parentheses, so that's how we know how to multiply, as opposed to add or subtract in the previous problem. So this is another FOIL example. So FOIL with me, please. First, -4 times -4?
16.
16. Outsides, or distribute. -4 times -5i.
20 plus 20i.
Negative times negative makes it plus 20i. Insides, or start distributing the 5i. 5i times -4? Negative or minus 20i. And then last, 5i times -5i. Minus 25i squared. That's FOILing. You weren't here, you missed it yesterday. Even though it's an I, and we'll review what I means here in a moment, we kind of treat it like a variable in this case, don't we? Okay, whether it be I, X, exactly along the way. Now, what pieces do you recognize here? What are some of the things we can do at this point?
Well, you can, since you have I squared, you can change the sign in front of the 25, which obviously that's going to be -1.
Okay, so one thing we talked about yesterday, if you go back to the very first page of notes, I squared is defined to be -1. I should never see an I squared in a final answer. Math Excel will never want to see I squared. I'll never want to see I squared, because I squared always turns to -1. And so then we're doing -25 times -1, and -25 times -1 is really going to become a plus 25 there, isn't it? Okay. What else do you notice?
The I basically just canceled.
We always want to check into these like terms when we're FOILing. And in this case, we have 20i minus 20i, which just so happens to cancel out. What else do I have in my answer?
The 25 and 16.
We had a 16. So we have a 16. My middle's all canceled. And I have a plus 25.
You can add it together.
Yeah.
What is 16 plus 25?
41.
Is he right?
Yeah.
I'll be honest, I hadn't thought about it. So, final answer of 41?
Sure.
Okay. Yeah, I got it. I've had time to do the mental math now.
Very good.
I just, usually I've done the mental math ahead. That one, I was behind a step. I don't know. Okay, guys. Now, this example is specifically here as we lead into the next section. Okay? I don't remember if you've heard these words or not, but this example, D, these pieces are what we call conjugates. I'm not sure if you've heard the word conjugates or not. I feel like you might have back in Algebra 1, but it's been a while. You've slept a lot since then. But these are conjugates because what do you notice about these parentheses? They're pretty much identically the same, except that middle sign. And when you multiply two sets of parentheses that are identical with the exception of the middle sign, they're called conjugates. And guess what's always going to happen? My middle terms that canceled out here, those middle terms will always cancel out when you multiply conjugates. Okay, every time. Those middle terms will cancel out. Okay? So questions on this one? Remember how to FOIL from yesterday, right? Okay. So moving down to the bottom of the page. In the bottom of the page, and I don't think we're going to do all 4 of these, probably just 2 of them will be plenty. But it talks about, okay, how do we divide complex numbers? Example A there says 9 plus 12i divided by 3i. And notice what it says up here above this. In order to divide complex numbers, you multiply the top and the bottom of the fraction by the conjugate, and it should say it's the conjugate of the denominator. Okay? So, for instance, if the denominator is 5 plus 2i, we multiply by 5 minus 2i. So we're going to multiply by, and I think I'm going to write by the conjugate. And this should say of the denominator. And when I say denominator, I'm referring to the bottom of the fraction, right? So, and what this all comes down to, folks, is when we leave these fractions, we can't leave a fraction with an I in the denominator, okay? Because I represents a square root. And if you recall from past, we can't leave a square root in the denominator. So we can't leave an I in the denominator. Okay, so this kind of goes along the lines of rationalizing, which I know we haven't really dealt with square roots this year yet. That comes up second semester, where we work with square roots and how to rationalize and all that, but a little review from Algebra 1. Okay, so looking at A. My denominator is a 3i. Kind of a weird one to start off with, but that's all right. Thoughts on what the conjugate of 3i would be?
Negative 3i.
Why negative 3i?
Because it's the opposite of 3i.
Okay. So if we think about this 3i, little side note here, as a complex number, could you agree that 3i is 0 plus 3i?
Yeah.
So what would be the conjugate of 0 plus 3i?
0 minus 3i.
That would be 0 minus 3i. Am I making sense there?
Yes.
Now, so 0 minus 3i, do we really have to write the 0 though? We don't. So what we're going to do is we're going to multiply by negative 3i. Whatever I do to the denominator of a fraction,
Yes.
we do to the numerator. That's old news, right? So we're going to multiply the numerator and the denominator by this negative 3i. Okay. Thoughts on top. How do I multiply 9 plus 12i by negative 3i? What do we have to do there? What do you think, Lorna?
Multiply each part, so like minus 3i times 9, minus 3i times 12i.
Yep. So she says multiply each part. The fancy math word is to distribute. We're going to take this negative 3i and we're going to distribute it to the 9 and distribute it to the 12i. Now, I know that looks a little backwards, but that's all right. Okay, you can distribute from the back. That is perfectly fine. So, what is 9 times negative 3i? Negative 27i. And then what is 12i times negative 3i?
Minus 36.
Minus 36i squared. And it's important to know whether it's I or I squared, right? When you do I times I, it's I squared. Denominator. What's 3i times negative 3i?
Negative 9i squared.
3 times negative 3 is negative 9. I times I is I squared. Okay, from here, it's all about the cleanup. What is something you see in this problem that you know I'm going to say we can't leave?
The I squared. The I squared.
Yeah. I never want to see an I squared in an answer, right? And that's just me talking. That's not even Math Excel. Math Excel will definitely count you wrong. So what do we know about I squared? Every time we see an I squared,
We take it away and we change the
change the sign for
Check sign. Yeah.
Okay, you change the sign basically. You can drop the I squared and change the sign. I squared is officially equivalent to -1. That's what you need to know. That's the official math. Now, I know some of you much prefer the shortcuts. Not what I'm supposed to teach, but I know some of you prefer the shortcuts, and so knowing that basically you can just change the sign is equivalent. So if we rewrite this now, -27i is still -27i. Minus 36i squared is equivalent to plus 36. Because it'd be a minus 36 times a -1, which is a positive 36. Denominator, -9i squared. Well, that's really -9 times -1, which is positive 9. Okay. We're not quite done. First of all, you will always want your answers expressed in A plus BI form. Is this in A plus BI form?
No.
Okay. You're not going to be allowed to leave it. I don't think MathXL will allow you to leave it as one fraction like this. So what do we know about that denominator of 9? That denominator of 9 goes with
36.
It goes with both of them.
It goes with both of them, right? It goes with the 27i and the 36. And so I'm going to write this out. I'm writing too big. -27i over 9 plus 36 over 9. In other words, that denominator, when you have one denominator, it goes with multiple pieces of every piece of the numerator, every term. So in this case, both terms. What do you notice about -27i divided by 9?
It's 3i. So negative.
27 divided by 9 is
Negative
3. Negative divided by a positive is negative. So this is equivalent to -3i. Plus, what do you know about 36 divided by 9?
4.
4. So -3i plus 4. Now, small technical thing. If we're talking A plus BI form,
It's 4 minus,
what should be the more traditional?
4 minus 3.
Flip it around, and it's a positive 4 and a minus 3i, so 4 minus 3i. Okay? Please try and be in that habit of doing the A plus BI form. Again, I don't know, MathXL might be able to put -3i plus 4, and MathXL might go for it. No guarantees, though. Okay, and I guess if you guys run down into C and D, I'm not necessarily planning to do C and D because we still have some equations to solve on the next page, so I want to make sure we have some equation solving time. Let's talk about B though. It's a fraction. 2 plus 3i over 1 minus 4i. I can't leave it as a fraction. I can't leave an i in the denominator. How do we, quote, divide these complex numbers?
You multiply by the argument of the denominator. So it would be 1 plus 4i.
Okay.
Right?
Is he making sense? I mean, he read part of that right up there. Multiply by the conjugate, right?
Of the denominator.
Specifically of the denominator. So my current denominator is 1 minus 4i. What's going to be the conjugate of 1 minus 4i? 1 plus 4i. If I multiply the denominator by 1 plus 4i,
The top.
we're multiplying the numerator by 1 plus 4i. Okay? How do I multiply my numerators? Distribute. You could also think FOIL if you want. Same thing, right? Distribute's the official mathematical term. If I say FOIL, though, that clues some of you guys in that we're going to have 4 terms here. So, here we go. First, 2 times 1. 2. Outside, 2 times 4i
8i.
plus 8i. Insides, 3i times 1
3i.
is 3i. Last, 3i times 4i.
12i. Squared.
I say, did anyone say the squared originally?
No,
3i times 4i is
12i squared.
12i squared. You leave that I squared off. Bad news, folks. You've just ruined your whole problem because it's not working out right. Okay? Okay, denominator. We're going to FOIL. First, 1 times 1,
1.
1. Outside, 1 times 4i
4i.
plus 4i. Insides, minus 4i times 1
Minus 4i.
minus 4i. And last, minus 4i times positive 4i.
Minus 69 squared.
Minus 16i squared. Okay. Notice when you FOIL like this, we have a constant, 2 I terms, and an I squared term. That's what you would expect. Okay? Let's see. Some serious cleanup, I hope. What kind of things do you see when we clean up this fraction?
Well, you got the I squared, which will just basically change your signs because they're negative ones. So your positive 12i squared becomes negative 12. And then your negative 16i squared becomes 16.
So my I squareds become negative 1, and those will change things.
The
And
4i and the
Oh yeah, the 4i minus the 4i, those cancel. Leaving you with 1 plus 16. So then you used to add 1 plus
Okay,
16.
hold on.
17.
yeah. I was,
I'm not there yet.
I am.
Hold on.
saying that, you know.
Okay, slow down here. So, okay, on the bottom. And guys, do we expect this?
Yeah.
Should these 4 I's be canceling?
Yes.
Yes, if they don't, you need to back up and see what you did wrong. Okay? On top, what do we notice on top? 8i and 3i are like terms, yes?
Yeah.
So you've got I squared to turn to negatives, and you've got i's, which are like terms. So on top, if I clean this up a little bit, I'm going to take baby steps because I don't want to lose anyone. There's a 2, right? 8i and 3i is
11i squared.
11i.
11i. If I add 8 of something and 3 of something, that's just 11 of the same thing.
Yeah.
And then this plus 12i squared, well, if I squared is negative 1, 12 times negative 1, minus 12. Now, some of you may have gotten fancy, and you may have gone ahead and done 2 minus 12. That's fine. For the rest of us, I'm taking the extra step. I'll get fancy here in the next step. Okay? Denominator, we still have a 1. 4 i's cancel. Minus 16i squared is going to become plus 16. And if you don't like my baby steps, just jump ahead of me.
Okay.
Justin's going to jump ahead of me. Whatever. I don't care. Okay, clean it up again. On top, if you didn't already, 2 and minus 12 is negative 10 plus 11i over 17. Again, I didn't think to look at Math Excel. Your math teacher is failing you on that. Sorry. But I really don't think Math Excel is going to let you leave it like this. They're going to want an A and a BI. So what's that mean? This 17 goes with,
Negative 10 and 11i.
yeah. So we're going to have negative 10 over 17 plus
11i.
11i over 17.
That's right.
Last time they reduced.
They got
Do we have the reducing this time? No.
your answer.
Now, I will mention, I is kind of like a variable here, right?
Uh-huh.
Options for where you can put the I. The I can be in the numerator. It can be next to the fraction. It cannot be
And then
in the denominator. So you can have 11I over 17. You can have 11/17 I, but you cannot say 11 over 17I. That is not the same. Okay? And Math Excel should be flexible, I think, with where you're allowed to put the I. Okay. Are you getting the idea here of multiplying by the conjugate?
Yeah.
And it's a lot about foiling, which we did. I'm pointing to the sky here, up above, right? You foiled up above in your notes. It's a lot about that. Okay. Can you guys handle it if I skip the next two and go to the next page and we solve some equations?
Will the notes be posted, or like, can you like write down the answers for those?
I can. I don't have them right here, but I can grab them here at the end. Remind me, okay?
Okay.
Okay. On the third page of notes, yes, we have a third page if you didn't figure that out, okay? On the third page of notes, we have solving equations. We're going to solve using square roots. We're going to solve using quadratic formula. I'm going to argue that I'm not teaching you anything new here, because I already taught you how to solve using square roots back in lesson,
4.5.
that's kind of my guess. Is that your random guess? 4.5-ish. Okay. I taught you quadratic formula in 4.7.
Yeah,
Reading my mind. Okay.
4.5 and 4.7.
I've taught these. It's just a matter of now, what kind of answers are we going to get today? Are you going to guess?
Alright.
We're going to get imaginary answers, aren't we? So we'll talk about what that means. Okay. So go back, dig in your brains to lesson, actually, this is going to be lesson 4.6, because I taught this when I taught completing the square. Okay? What do you notice about the examples here?
Equal to 0.
Well, they happen to be equal to 0. Not what I'm going for.
Darn it.
Valid point. What kind of terms do we have?
We have an x squared.
We have x squareds, and we have numbers. What do we not have?
Factor.
We don't have any,
Complex numbers.
well, okay, listen. We have x squareds. We have numbers.
We don't have the regular ones.
We don't have any x's, which means we're not doing our traditional product and sum. We're not doing quadratic formula. You guys remember me teaching this?
Yes.
Solve to get x squared by itself. So if I have 2x squared plus 32, how do I get x squared by itself?
Squared.
First step is what?
Squared.
You have
Listen to my question.
You have to do the 2.
You said, I'm just
Get
going
rid of
with
two.
Okay. Quit talking so much and listen to what I'm asking then. How do I get x squared by itself?
Divide by 2.
I don't want to divide yet.
Get rid of 32 first.
How do I get rid of 32?
Subtract.
We're going to move the 32 to the other side. Okay? And I'm not saying you couldn't divide by 2 here, but occasionally it won't work out nicely. Okay? So I would always suggest get the x squared term by itself, which means if it's positive 32, we're going to subtract 32. What do I have after I subtract 32 there? We've got 2x squared, and 0 minus 32 is negative 32. Is x squared by itself yet? Not yet. I've got the x squared term by itself. How do I get x squared fully by itself?
No. Yeah.
Now I'm ready to divide by the 2 that I said not quite yet earlier. And it would have worked out the same earlier, but there's times it won't. So divide by 2, because I'm trying to get x squared by itself. So now I end up with x squared equals negative 16. That negative is important. And here's the difference, folks. When I taught this back in lesson 4.6, we would have had positive 16. But today we have negative 16. Okay, if it's x squared equals negative 16, how do I get x squared to become x?
So we got a square root of negative 16.
Do you remember square rooting? If we square root the left, we square root the right. The square root of x squared is x. What is the square root of negative 16?
4.
And
Plus or minus.
Remember plus or minus for I?
No.
Dig deep. I taught it back in lesson 4.6, I promise. Okay, it's there in the notes. But, okay, so do we need a sidebar here? Did you guys figure out the square root of negative 16?
Yeah.
Negative 16 is negative 1 times 16, yes? And what's the square root of negative 1?
5.
That's I. What's the square root of 16?
4.
4. So when you see square root of negative 16, the negative says I, square root of 16 is still 4. Anytime we take the square root in an equation setting, we're going to say plus or minus 4i. That seems a little familiar, doesn't it?
Yeah.
It's this chapter. So, throw Thanksgiving in there and it seems forever ago. Okay, try B with me then. 5x squared plus 20 equals 0. Note, I got an x squared term, I got a number term. I got no x term, so if I have just x squared or just x, get it by itself. How do I get the x squared term by itself?
Subtract 20 from the other side.
Okay, start by subtracting 20. So then I have 5x squared equals negative 20. Now how do I get x squared by itself? If it's 5 times x squared, we're going to divide by 5. X squared equals negative 20 divided by 5 is negative 4. What is the step I take to solve for x? If it's x squared, the square root of x squared is going to be x. Square root of negative 4.
Plus or minus 2i.
Okay. Okay. So the square root of 4, that's the obvious part, right? Square root of 4 is 2. The square root of a negative says I'm going to put on an I. Because I took the square root in an equation setting, we always have to account for the positive and negative solutions. Now, I would skip this next one, move on, but this is a good one to look at too, isn't it? For those of you that are ahead of me a step. Okay, same steps, right? X squared plus 15 equals 0. Get x squared by itself. How do we get x squared by itself?
Subtract 15 from both sides.
Okay. These steps should be becoming easy at this point. So x squared equals negative 15. If it's x squared, and I want to solve this, what do I do?
Square root it.
Square root. The square root of x squared is x. The square root of negative 15.
I'm out.
I think you got all the right pieces. I'm going to put them in a different order. But so first of all, when we take the square root in an equation setting, we're still going to put on a plus or minus, yes? You see a negative in there. What do we mean? The square root of a negative is going to become an I.
I times.
What's the square root of 15?
That's the square root of 15.
It's some decimal, and so we're going to leave it as the square root of 15. So my answer is going to be written as plus or minus I times the square root of 15. I think you originally said I at the end, which is fine. It's not necessarily wrong to put I at the end, but common mathematical practice is to put the I out front, because if we put the I at the end, it can, depending on how long you make that square root sign, it becomes a question of, oh, is it under the square root or is it outside the square root? If we put the I out front, we know it's outside of the square root. Okay? The This wasn't too bad, was it? Okay. I got one more topic for you.
Oh boy.
And again, I'm going to argue I'm not teaching you anything new. You already know what to do. I'm moving to another page so I have more room here. As you look at these problems, the difference from the last section is that now we have x squareds and x's, don't we? So when you get those x squareds and those x's, it's no longer, okay, get x squared by itself or get x by itself. It's make your equation equal to 0. So we can use the quadratic formula. Okay, these are the type, and I guess I should have addressed factoring. You can try to factor first, but guess what? They're not going to factor. Okay, so you want to make your equation equal to 0. You guys remember your quadratic formula?
X equals minus b plus or minus the square root of b squared minus 4ac over 2a. Okay, then.
Sure.
Yeah, I remember that.
Good job, Lorna.
I was singing the German dude song in my head.
Okay, so write it in your notes somewhere, or flip back to lesson 4.7. Okay, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Sorry, mine got a little sloppy there. Okay? Your excuse when doing homework should never be, I didn't know the quadratic formula, so I couldn't do homework. That's not a valid excuse in my mind. A, it's in your notes. B, can you always Google the quadratic formula?
Yeah.
You guys all have your phones sitting beside you when you're doing homework. So Google the quadratic formula. Or you're on Math Excel, which means you're on your iPad. Google the quadratic formula. No excuses not to be able to get the quadratic formula. Okay, so on A, first question that you're supposed to be asking yourself. Does your equation equal 0?
Yes.
Yes. You guys want me to do ABCs?
Yeah.
It's up to you, right? It equals 0. What's A? 2, because it's in front of the x squared, right? What's B? Negative 3, because it's in front of x. And what's C? 5, because it's a number hanging around at the end, yes? Again, if you don't remember your ABCs, look back to lesson 4.6 or even before. Okay, here we go. X equals negative b. What do I mean negative b here?
Be a positive.
It's a negative of negative 3, so positive 3. Plus or minus the square root of b squared. So I'm going to write in negative 3 squared minus 4 times a, which is 2, times c, which is 5, all over 2a, which is 2 times 2. Folks, this is key. I've told you guys, quizzes, tests, this can earn you a point. You can at least write it down right. Okay. 3 plus or minus. What do you see going on under that radical? Negative 3 squared is, negative 3 times negative 3 is 9. Sorry, I was just going to do that part. And then 4 times 2 times 5 is 40. And there's just a minus sign, so it's 9 minus 40. All over 2 times 2 is 4. Okay, keep going. What do you know about 9 minus 40? 9 minus 40 is what? Negative 31. So now I'm at 3 plus or minus the square root of 31, square root of negative 31 all over 4.
So then you have to do
3 plus the square root of negative 31. We have to do 3 plus or minus I times the square root of 31.
And you can actually leave it as plus or minus. But here's the deal. You can't leave it as the square root of negative 31. What do we know about a negative under the radical? It's an I out front, yes, or outside of the radical. So 3 plus or minus I square root of 31 all over 4. And I guess I didn't address it. Maybe I thought it was obvious. Square root of 31 is square root of 31. There's no perfect squares in there, right? Now, I'm really thinking Math Excel won't let you leave it like this. I could be wrong. I hope I'm wrong, because this would be the easiest way to leave it, yes? But they're going to want it in A plus BI form. Which means, okay, what do we know about this denominator of 4? It goes with both pieces. And so one way to write this is 3 over 4 plus or minus I square root of 31 over 4. And I don't know, maybe I'll let you leave it as one big fraction. Give it a try and see what happens. I just can't guarantee it. So that's one way to write your answer. And those don't reduce, so I'm just going to leave them. And I am going to throw on here real quick, just because I want you guys to see it. The other way to write this is still 3/4 plus or minus, but I want you to realize you will sometimes see, instead of putting the I in front of the radical, they'll put it after the fraction. So 3/4 plus or minus square root of 31 over 4, and then times the I at the end. Those are both good equivalent answers. And Math Excel should definitely be fine with either of them. There's a chance Math Excel will be fine with this previous line. Don't count on it though. Just be excited if it works, right? Okay. I wanted to do one more quadratic formula. And if I do one more, I don't remember how, I want C because I know there's some reducing at the end I want to talk about. So can we go through C real quick? Let's try C real quick. What's your first question to yourself?
Does it equal 0?
Does it equal 0? Yes. If you want them, you can write them down. What's A? 1, because it's in front of x squared. What's B?
Negative.
Negative 4, because it's in front of x. What's C? 5. And if it, I'll put it over here in the middle, but there's your form, right? Ax squared plus bx plus c equals 0. Throw that in the middle for you. Okay, quadratic formula, here we go. X equals negative b. What's negative b going to be? Positive 4 plus or minus the square root of b squared minus 4 times a times c all over 2a. So in my square root, I did negative 4 squared minus 4 times 1 times 5 all over 2 times 1. Okay, moving along so I don't run out of time. 4 plus or minus the square root of 16 minus 20
Over 2.
all over 2. 16 minus 20 is
Negative 4.
-4. So now I have 4 plus or minus the square root of -4 all over 2. What do we know about the square root of -4? There's a -1 and a 4. The square root of -1 is I. The square root of 4 is 2. Sound familiar? You're getting better at that, right? So 4 plus or minus 2I all over 2. You definitely can't stop here. Math Excel will be unhappy, I'll be unhappy, everyone's unhappy. So, what do we know about that denominator of 2?
It can go into 4 and 2.
Yeah, it goes both places. It's 4 divided by 2 plus or minus 2I divided by 2. Don't stop here. 4 divided by 2 is 2 plus or minus 2I divided by 2. I would just say I. You could say 1I, but again, I don't think Math Excel will be happy with 1I. Okay?
Will you put the answers up for the other one?
I will get them here in a moment. Yep. Okay, your homework is lesson 4.8 in Math Excel. It's due when? Tomorrow. No excuses. It's been open since last Monday. So get it done.